Okay, let's finish up our notes for section 7.6 with one more example here. You can see the rest or the answers to the first example if you didn't check out that video. But we're going to look at this second example here. In this case, what I want you to really notice is that the x and the y are inside the triangle. So I know that this right triangle features a 90-degree angle, but other than that, I don't know the measure of this angle x or the other angle y. So that tells me that my first step, well, I have a few options for the first step, but my first step is going to be to figure out those angle measures. If you wanted to, you could use the Pythagorean theorem to solve for the hypotenuse because you know the length of two of the legs, so you could do a squared plus b squared is equal to c squared. In this case, what you don't know is your hypotenuse. That's the leg that you don't know. You know the other two legs, the 7 and the 11. So since the hypotenuse is the side that's opposite the right angle, z is your hypotenuse. Since I need to solve for both of these angles, I have to pick an angle of reference first. I'm going to choose x because it's first alphabetically. X is made by the hypotenuse and the adjacent side. The adjacent side in this case is the side length that measures 11. What I'm trying to do is solve for the measure of that angle, so I'm going to say that my theta is x. However, I do need to find the measurement for y. The next thing I'm thinking about is if I've chosen for theta to be x, that means that the opposite side has to be 11. If I'm going to use trig, I'm going to have to use trig to solve for an angle first because I don't have either of the angles on the inside. So I can't use trig to solve for the hypotenuse. I could use the Pythagorean theorem, but we're not there right now. So right now, if I'm trying to find the measure of angle x, I have the opposite side and I have the adjacent side. So I can use the tangent of x and I can fill in opposite and adjacent with the actual side length measurements. The opposite side was 11 and the adjacent side is 7. Tangent is the only trig function where you can have an improper fraction like this. Every other trig function should have a proper fraction. If I want to find the value of an angle measure instead of a side, I have to do inverse trig. So the inverse of tangent is inverse tangent. If I take the inverse tangent of the tangent of x, basically I've undone the tangent function. So that's going to allow me to get rid of both of the inverse tangent and the tangent on the left. If I take the inverse tangent on the left-hand side, I have to do it on the right-hand side. So I have to take the inverse tangent of the opposite side over the adjacent side, which is the fraction 11 over 7. This is what's going to go into my calculator, but I want to clean this up just a little bit before I do that. I know that x is going to be equal to the inverse tangent of 11 over 7. This is a fraction that can't be simplified, but if it could be, just remember you don't need to simplify the fraction before you put it into the calculator. In this case, the most important thing is going to be to make sure that I use an inverse tangent. So when I use my calculator, I want to make sure I click on the tangent with the -1 exponent, and I have 11 over 7. I like to close the parentheses, but you don't really need to. Since I'm talking about an angle measure here, I'm going to keep with my suggestion of rounding to the nearest whole degree. So I'm going to say that this is 58 degrees, although if you want to keep it at 57.5 or 57.53, you are more than welcome to round however you want. I'm not going to be that particular about this. Now that we've used trig to solve for the first angle measure, we could use trig to solve for the second angle measure, or you can remind yourself that there are 180 degrees inside every triangle. There really is no reason to do trig more than twice in any of these questions. Generally, you can only do trig, you only have to do trig once, and there's going to be some other way that you can find the answer. But if you want to do trig to solve for y, you absolutely can. I notice that there's a 90-degree angle, and I just found out there's a 58-degree angle. I know that that third angle, that's y, has to come together so that all three of those angles make 180 degrees. This is something that I know is true about every single triangle. So if there are 90 degrees and 58 degrees, that means of the 180 degrees, 148 of them are being taken up by those first two angles. that means that whatever is left over is going to get me to 180 degrees. So if I subtract and I do 180 minus 148, that's going to tell me how many degrees are left over for that third angle. If you wanted to, you could absolutely use tangent again, and this would be the inverse tangent of 7 over 11, and you should get pretty close to the same numbers as what I'm about to write down. 180 minus 148 is 32 degrees. So at this point, if I have a 58 degree angle in a right triangle, the other angle has to be a 32 degree angle. Right now we've solved for both of the angle measures, so if I wanted to find the length of the hypotenuse, I have two different ways I can do it. I could use trig, I could do cosine, or I could do sine, because I know the adjacent and the opposite, and it's the hypotenuse I need in both of these. However, I also know that since this is a right triangle, a squared plus b squared has to be exactly equal to c squared. So what that means for me is if I label A and B as the two legs of the triangle, C is the hypotenuse. So A can be 7, I usually make A the smaller number, B 11 because it's the bigger number, and then C is always the hypotenuse in the Pythagorean theorem. So instead of C, I'm using the letter Z this time. Please make sure that your calculator is doing the heavy lifting here and not you. You can do 7 squared plus 11 squared right there, and it gives you 170. You don't need to worry about trying to do all that math in your head. Use a calculator. I know that 170 is z squared, but I don't want the squared value. So if I'm going to undo a square, I take the square root. And if I take the square root of 170, that's not something I can do without a calculator. So I end up with 13.038. I am going to keep this at, I think I'm going to go ahead and I'm going to write down 13.03 just because I want you to be aware that that is different than 13. If I told you that you were rounding and you rounded it to 13, that would be okay, but 7 squared plus 11 squared is not technically, the square root isn't really 13, so just know that there is rounding happening here. You have lots of different options. You can use 180 degrees, you can use trig, you can use the Pythagorean theorem. Choose the method that works best for you and ask questions when you have them.